So in the last class we study enthalpy of formation, thermochemistry we are.
Yes, sir.
So that is the same we are going to follow up today. So that is the enthalpy of formation. That is enthalpy of formation. Enthalpy of formation when
Yes.
bond energy given. They are saying when bond energy given. So that is how much heat change when the product is forming. That is what they are asking. Okay. So I told you
Yes,
thermodynamics
sir.
is all about the change in the energy and all. So that is work done. This all we have already done. Now the last part we are running, that is enthalpy. So if we talk about that is how much, if suppose the 1 mole of product is being formed, so how much energy is being released, that is what the enthalpy of formation they are talking about. Okay. So similarly, let's try to understand the concept here, what we can do. That is amount of heat change when amount of heat change when uh, they are saying when the no bond enthalpy bond enthalpy of reactant is given is calculated by how they are going to calculate it, is calculated by,
Yes,
so
sir.
that is delta hf is equal to delta h, no summation we have to write, that is summation delta h bond enthalpy. Here I am writing that is reactant, summation of reactant.
Okay, sir.
So delta H bond enthalpy, that is BE of reactant, minus delta H. They are talking about summation of delta H BE of product. So that is how much amount of energy is produced for the reactant and how much is, that is product is there, that we have to subtract. Now how can you
Yes,
be
sir.
able to understand this one? Okay. So if suppose you, if one
Yes.
question is there, question, if bond enthalpy bond enthalpy of reactant is 100, kilojoule, and product is, they are saying, and product is 120 kilojoule, 120 kilojoule, then find enthalpy of formation. Then find enthalpy of formation. So this is the very simple problem where what is there, that is as a whole summation they have given. So if you are writing that is delta hf, so that is what can we write, that is summation of delta h be. You can write here the reactant. Okay, minus
Yes, sir.
product we have to do, that you need to memorize, that is reactant minus product. Otherwise some student, what the mistake they do, that is product minus reactant they wrote, that is the incorrect. So
Yes,
delta
sir.
H bond energy of, that is going to be product. So let's try to understand this one. So that is bond energy of reactant, they are saying that is how much is there, 100 kilojoule. So here is 100
Yes, sir.
minus bond energy of product, they are saying that is 120. Okay, this they are saying. Now they are talking about how much energy is going to change. So 100 minus 120, so it is coming minus 20. So that is delta H value is coming. Delta H means negative. And I told you, what I told you, if delta H is coming negative, negative means exothermic. Negative means
Yes,
exothermic. Okay, and if delta H is coming positive, so positive means going to be endothermic. Endothermic.
yes, sir.
Negative means energy, exothermic means energy released. This is what is energy released. And here is
Okay, sir.
energy absorbed. So that is a little bit concept is there that we need to keep in mind. So here you see they are saying minus 20 kilojoule. So how much product is formed? How much enthalpy change when one product is formed in the reaction? That is minus 20 kilojoule. Can you be able to
Yes, sir.
understand this?
Yes, sir.
Okay. So
Yes, sir.
formula, or at least formula, only formula
Sir,
you.
wait, sir. I'm writing, sir. Just 1 minute.
Okay, no problem, no problem.
Done, sir.
Thank you. So let's try to solve the problem based on it. Today we will be able to solve some of the problem. So question number one we are writing. Question number one. What is the question? Bond enthalpy of bond dissociation enthalpy of they are talking. Bond dissociation enthalpy of following are as following are H. So they are talking H bond H, they are talking 100, okay, kilojoule. They are talking kilojoule. And they are Br bond Br, they are talking about that is 50 kilojoule. And last one HBr, they are saying HBr. So they are talking about 90 kilojoule. Okay. Then
Yes, sir.
find delta HF. Then they are saying find delta HF enthalpy of formation. Option they have given how much minus no plus 60 kilojoule per mole they wrote. Then they have
Yes, sir.
minus 60, minus 15, minus 30. So this is the A number. Here is the going to be B number, C number, D number. One more thing they have given, equation they have given H2 plus Br2, they are giving 2HBr. So these things they have given. So how can you be able to solve? Let us try to solve the problem. So here we are writing the solution.
Yes, sir.
So formula, I am writing the formula first. So formula is what? Delta HF is summation. Summation of, that is, here we can write that is reactant. Summation of reactant. Delta H bond enthalpy of reactant. This is 1 minus. Again, summation we are putting. Here is the summation of, they are talking about product. Delta HBE. So this bond energy is
Yes,
for
sir.
the product, okay, that you need to keep in mind. And this bond energy is for reactant. Either you place the value for the in this equation, otherwise you separately calculate for reactant and then product, then solve. Otherwise you can place the value for the same. See. So
Yes, sir.
if you talk about this one, 2HBr is there. So how can you be able to solve the problem? Okay, that
Yes, sir.
find out. So here you see this value, you see how many in this reaction. If you writing, I'm writing the reaction in different way. Let's try to understand. If you be able to understand,
Yes, sir.
here is H bond H is there, plus what is there? Br bond Br is there. Then it is going to be 2 HBr. Yes or no? Between HBr there is single bond. Is it okay?
Yes, sir.
Br2 means Br bond Br. H2 means H bond H. So here if you are placing the value, here if it is placed, if you are placing the value, so what is going to come? So what is going to come? See here.
Yes, sir.
What is going to come?
Yes.
One enthalpy of reactant. Okay. One enthalpy of reactant. So You see, these are the HH is reactant. So how many are
Yes,
there?
sir.
So 1 into H bond 1, that is H into H, plus what is there? Br is there. Only one is there. So 1 into Br bond Br. Then what they are saying? These are the reactant minus product. 2 into H bond Br. Yes or no? Yes or no? So that is you can write 1 into Be. Better we can write little bit, we can change here, because you should not get confused. That is all what I want. So Be of HH bond, then here is going to be Be of Br bond, and Be of what, that is HBr bond. So how much is going to be HH bond? How much is coming answer? So HS they have said that is 100 joule. Yes or no?
Yes, sir.
So I am mentioning here 100 joule, right? Then we
Yes.
are mentioning here that is Br, this is the 50. Then again here is, this is going to be plus. Here HBr how much is 90. But before that here is 2 is there. 2 into B. Why 2 I did here, Janam? Here the
Yes,
coefficient you
sir.
can see how many are there? 2 coefficient are there. Yes or no?
Yes, sir.
So here you see what we can do here in this problem. What we can do. So HBr value is 90. HBr is 90. Solve it.
Yes, sir.
So 100 plus 50, 150 minus 2 into 90, 180. So it is how much is coming, Janab? Can you tell me? Minus 30 kilo
Yes, sir.
this. So option number which is correct, option number D is correct. Can you be able to understand?
Yes, sir.
Hmm. Delta HF reaction they ask. Okay. Can you please write down this one? Are you writing?
Yes, sir. Yes.
Okay, okay. Done?
Yes, sir.
Can I erase?
1 minute, sir. Just
Ah, okay, okay, okay.
done, sir.
Okay, thank you. So what we are going to do, one more problem I'm giving you. Little bit. Here you see enthalpy of reaction. This one is there, enthalpy
Yes,
of
sir.
reaction. Okay, this is what the, if you are talking about enthalpy of reaction, so per mole is not there, because in the reaction here 2 mole is being formed. Here is 2 mole is being
Yes, sir.
formed. So reaction means that is how many moles are given in the reaction. That is what we have to take. Now see, I am writing the one point here, very important one. The separating this enthalpy of reaction, enthalpy of reaction, and enthalpy of formation. Enthalpy of formation. So enthalpy of formation means they are saying energy change or heat change. Anything you can write. Heat change for
Yes,
the
sir.
formation of, for the formation of what? For the formation of 1 mole of, for the formation of 1 mole of which things we have to write? Heat change for the formation of 1 mole of product. So here that is enthalpy of formation they are asking, means 1 mole we have to write. Here is enthalpy of reaction, means heat change in a reaction. Heat change in a reaction. Here moles is not specified reaction. That is, so
Yes,
here
sir.
we calculated for actually 2 mole. Okay, here is the 2 mole is there because here 2 mole. So we multiply here by 2. Now see, you keep in mind this point, please. In this question now, you keep in mind this one. So let's try. Okay, so they are saying H2. Okay, wait, little bit. They are saying question, calculate enthalpy of formation of HCl. Enthalpy of formation of HCl. Formation of HCl. Okay. So they are talking about what
Okay, sir.
HCl means, how many mole? 1 mole. In bracket, you can keep in mind 1 mole. That is what? 1 mole. Now, what the point they are talking about? What the point here? Talking about if bond dissociation enthalpy, if bond dissociation enthalpy, if bond dissociation enthalpy of following are H, following are H. How much they are talking about? H bond H, they have said that is 434 joule. This is comma. They are saying Cl bond Cl. They are talking about 242 joule. And last one they are talking about comma. H bond Cl 431 joule. So option A have they said that is minus 33 kilo and 30 joule, 93 joule. Okay, this is A number. B number plus 93 joule. C number, if you talk about C number, so 89 minus 89 joule, and D number plus 89 joule. They have said. So we need to solve it out. The one thing we need to keep in mind, the reaction. So how to write the reaction? We have to self write required reaction. So required reaction means 1 by 2 H2 plus 1 by 2 Cl2, then it is going to give HCl. Otherwise, some student how they wrote, they will write that is H2 plus Cl2, they will write that is 2HCl. So it is 2 mole. But here enthalpy of formation is talking about 1 mole. So 1 mole means you have to take half this, this will come now. Yes, yeah, no.
Yes, sir.
Okay.
Yes.
Now I am changing the equation. See how I am writing. 1 by 2
Okay, sir.
H bond H plus 1 by 2 Cl bond Cl giving what? That is HCl. Can we write like this?
Yes, sir.
Okay. Now calculate, that is delta HF. What is formula? So that is summation sign delta H bond energy of what? That is reactant. Here is reactant minus, here is summation delta H bond energy. This is going to be product. Okay. So
Yes,
reactant minus product. See. So here is
yes,
the
sir.
summation reactant bond energy of reactant. See, so what are the
Yes,
reactant?
sir.
H2 and Cl2. So half mole H2 is there. So energy will be half H bond H plus half
Yes, sir.
Cl bond Cl. Very tough. You need to be very careful here. And here is that is only one molecule. So we can write that is 1, and here is that is HCl. We have to write HCl. See, this we got. So what we are going to do here, what we are going to do, we are going to plug in the values because values are given. So here you see delta HF is equal to, see, bond energy of reactant. So HH bond is there, how much? 1 by 2. HH bond, you see how much? 434. So
Yes, sir.
434 plus 1 by 2 Cl2. Cl2 they have given how much? 242 bracket close minus
Yes,
one
sir.
energy of product HCl, how much is there? 431. Okay,
Yes, sir.
so directly there we can divide this one. 2 2 ja 4, 2 1 ja 2, 2 7 ja 14 plus 2 1 ja 2, 2 2 ja 4, 2 1 ja 2. This one. This is there minus 431. Here you see. Here is, this is the one, no? 718
Yes, sir.
213 213
Yes, sir.
minus 431. So obviously it is going to come negative because negative term is larger. So 431 minus 338. So how much is coming? 8 3 11. 11 minus 8 means 3 2. So 2. So 12 minus 9 9. So minus 93 joule.
Yes, sir.
Can you understand or it's very difficult?
It's a bit tough, sir, but yeah, I can understand.
Okay, okay. Because this type of on the basis of this, the problem asked in the exam that we have to understand.
Yes, sir.
Did you find that is A to Z book online?
Uh, no, sir. I found Pradeep books.
Pradeep book, no? Okay, okay, okay.
Yeah, that's much better comparatively.
Ha. Completed?
No, sir.
Okay. Done. Can I erase?
Yes, sir, you can erase.
Okay, thank you. So let's try to write down another problem. What the problem is all about. Here questions are there. So if you see last problem I'm doing on this one, then I'll change the heading. Okay. So better I will give you problem you can solve. Here question they are talking about using, they are saying using the following data, using the following data, calculate enthalpy of reaction, calculate enthalpy of reaction. Using following data, calculate enthalpy of reaction. Wait, I forgot the questions actually. Wait, let me check in the book. Using following data, calculate enthalpy of reaction. This they have said. So little bit more information is given, for which they are talking about, for which bond enthalpies are, for which bond enthalpies are. How much bond enthalpies they have given? They are talking about C double bond C. C double bond C is equal to 147. Okay. C single bond C, they are talking about 83. CH is equal to, they are talking about 99. And HH, they are talking about how much? 104 kilojoule per mole. They are talking about kilojoule per mole. So they are asking, we have to calculate equation they have given. C double bond C, here is H, here is H, this is H, and this is H. Then again they are talking about H single bond H. It is going to give this one, C single bond, here is H, H, here is H, here is going to be H, this is H, this is H. So reactant minus product we have to do. Answer they have said. A number minus 30 kilojoule per mole. Okay. B number option they are saying minus 60 kilojoule per mole. Okay. D number they are saying minus 90 kilojoule per mole. And this is C. And D number they are saying minus 120 kilojoule per mole. So these things they have given. So we need to solve this. Janav, how can you solve? So can you try this? So enthalpy of formation they are asking. Here even enthalpy of reaction they are asking. So but 1 mole is there, so there is no problem. So that is it will be equal. So delta HF is equal to what we can write, delta summation of delta H bond energy of what we have to write, that is reactant, minus summation of what product, and what we have to write, delta H bond energy. So that is reactant minus product. So what we will be able to do here, can you please see? Can you please help me to understand this? Are you listening?
Yes, sir.
हाँ.
I am.
ओके, थैंक यू. सो अगर आप देखें यहाँ पे तो सी एच बॉन्ड आर 4, यस या नो? So 4 into what we can write, 4 into C bond H. Can you be able to understand? See how many bonds CH are there? 1, 2, 3, 4. Yes? Tell me. Okay. 1 into C bond C. Then what is there? 1 into, it is coming H bond H. Is it audible, Janab, or is it stucking to you? Any problem are you facing? Janab, is it audible to you?
Hello, yes, sir.
Acha.
Sir, can you hear me?
Yeah, I am listening. I thought that is you are not.
Sir,
Mhm.
no, there's some disturbance my side, so I can't means like.
Oh, okay, no problem. So this is what a little bit patiently we have to see. Otherwise, this is little bit. Although it is easy, but what it is, what we find that if we lose the little bit concentration, so it will be out. So here, so reactant we wrote. Now we are going to write the product. So product, what are bond are there? CH. How many bonds CH are there? Can you count in the product? How many CH bond are there? How many CH bond are there in the product?
Sir, CH 1, 2, 3, 4, 5, 6, sir.
6. 6 into, we can write that is 6 into CH. Then what other type of bond is there in this compound? What other type of bond is there in this compound?
Sir, hydrogen, no, carbon compound, sir.
Thank you. Thank you.
One
Thank you.
carbon compound.
Thank you so much. So 1 into, we can write carbon bond carbon. Okay. So these are the things we got here. What we got here, 4 bond are there, that is CH bond are 4, that we can mention here 1, this is 2, here is 3, this is going to be 4. HH bond is 1, so I mention 1. C double bond C is there 1, so I mention 1. Then here what is there, 6 into CH. So let's try to plug the value. So 4 into CH bond energy they have said here somewhere. CH 99. So that is I wrote here 99 plus 1 into CC bond. So C double bond C is how much is there? Here is 147. So I wrote 147 plus HH bond they have mentioned how much? 104. 104. So this we have to multiply in one bracket is okay, and here is minus. So what is the, what we can write here is, if you are writing, so 6 into CH bond. So if you see CH bond, how much energy is there for CH? 99. 6 into 99 plus 1 into C, the single bond C. Where is C single bond C? C 83. Here is simple 83. Now let us solve. Janab, try to solve it out, please. Solve
Yes,
this.
sir. 4 into 99, 36. 6 plus 3.
Hmm.
36 plus 3, 396, sir. 396 plus 147 plus 104.
Oh, thank you.
Then,
Hmm.
wait, sir. Wait, just a minute.
396 you are saying, 146 plus 104. So we can write here how much is coming. 396, 140, 104. It is coming something
396.
640.
Wait, sir. Wait, I'm doing.
Okay,
147 plus 104. Sir, it's 670, 647, and the other is
thank you. 647.
plus 677.
So you are saying plus 670.
Minus. Yeah, minus
Yeah.
677.
So what is the value is coming?
677. Sir, minus 30.
So it is coming minus
Option A.
30. Option A. So it is coming kilojoule per mole. So correct option is option number this one. Thank you so much. So will you write this please? Done. Done. Done, Janab, done.
Yeah, done, sir.
Okay. So I am erasing and I am changing the topic. Okay. So here, what we can do, let me change the topic here. So this is the questions. Okay. Hydration, the topic which we are changing, that is hydration enthalpy. There is going to be hydration enthalpy. Okay. What is hydration enthalpy? Amount of energy released. Amount of energy released,
Yes, sir.
or they are saying in bracket change. Okay. They are talking about change when one mole of ionic
Yes,
compound,
sir.
one mole of ionic
Ionic
compound
compound.
dissolve in water, dissolve in water to form hydrated to form hydrated compound to form they are saying to form hydrated compound. They are
Hydrated compound.
hydrated compound. Now, what we need to do here, see, such as example, see, they are saying like copper sulfate is there now. If you are putting in the aqueous solution, that is water, so it is going to form CuSO4.5H2O. If I am talking about FeSO4 is there, if you are putting in the aqueous water, so it is going to form that is FeSO4.7H2O. Okay. If BaCl2 is there, if you are putting in the water aqueous solution, it will form that is BaCl2.2H2O. So these are what? That is hydrated salt. They are the hydrated salt, and they are the no water is there. So that is what is known as anhydrous salt. This is going to be anhydrous salt. Getting my point? Yes or no? Okay, so this is the definition. Okay, so they are saying that is we need to calculate that is hydration enthalpy. So what the condition we have to apply, that is amount of energy release or change when one mole of ionic compound dissolve in H2O to form hydrated compound. So that is firstly you write down, and then we have to solve this one. We'll give the problem on it. Please write down this.
Wait, sir, I'm writing.
Okay, no problem. Completed?
Just last.
Hmm. Done?
Yes, sir. Done.
Okay, thank you. So here, let us try to solve one problem. At least one problem, if you can understand, that will be the, this problem is applied for all no, any of the hydration enthalpy problem will come, that is same concept we have to apply, same trend. They are saying enthalpy of solution, है enthalpy of solution. We are talking about enthalpy of solution for BaCl2 dot 2H2O, BaCl2 dot 2H2O and BaCl2, okay, are respectively, they are wait, are, they are talking about how much is there here, are 8.8, 8.8 and 20.6 kilojoule, okay, kilojoule per mole, kilojoule per mole respectively, per mole respectively, per mole respectively. So they are saying calculate heat of hydration of BaCl2. Calculate hydration enthalpy of, better you write this one, hydration enthalpy of, calculate hydration enthalpy of BaCl2 to BaCl2 dot 2H2O in bracket solid, they are talking about. Option they have given, A number how much? Minus 29.4, B number option that is 30.4, C number minus 34.4, and D number option we have to give minus 35.5. Okay, in the next class we'll solve the, because this chapter is going to over now, within, you know, this
No,
week,
sir.
this week it is going to over, because I need to teach, that is entropy, second law of thermodynamics, entropy and Gibbs free energy. So little bit it's left, then we have to solve the problem from your book only. So what we can do here, let's see solution. If you are writing, that is little bit you will find here. They are saying enthalpy of solution for barium chloride dot 2H2O. So barium chloride dot 2H2O and a are barium chloride solid also, they are saying 8.8 and 20.6. So what we can do here, barium chloride is there, okay, and if you are talking about barium chloride, it is having, if you are adding, that is water molecule, so it is going to give, this is barium chloride BaCl2 dot 2H2O, this is going to give, okay. Now one thing is there, this we have to take, that is aqueous salt, you can take this one aqueous salt. Another one also you need to take, that is if BaCl2 dot 2H2O, it is forming what, this will be the hydrated, but it is also will be the solid only. One second. Okay, so they are talking about that you need to take this one aqueous solution in water, so it is forming, this is solid if it is forming, So that is what they are saying, that is aqueous will be out. So they are saying barium chloride salt aqueous condition, if you are putting in the water, so barium chloride dot 2H2O solid will form and aqueous will be the moisture. Aqueous means moisture will be out. Now the another condition they are saying, another point they are saying, if you are having, what we can do, if suppose barium chloride is there, barium chloride, and little bit it is aqueous medium is there. So what they are saying, BaCl2 and aqueous, these things they have given. See, enthalpy of solution of barium chloride dot 2
Yes.
H2, no, and barium chloride are 8.8. So this one is this one for barium chloride dot 2H2O, they have given 8.8, 8.8. Here is there. Now they are talking about BaCl2. This one they are talking about, that is how much is there? 20.6. This is 20.6. This is again kilojoule per mole, and here is also talking about kilojoule per mole. Kilojoule per mole. So little bit it is getting tougher for us. So now see, you added the barium chloride in the aqueous solution. If you are adding, so barium chloride aqueous medium is getting formed, and barium chloride aqueous in the water, it is getting barium chloride BaCl2 dot 2H2O plus aqueous. They are saying the other things we don't require, the aqueous left side and aqueous right side not required. Now another thing, what is not required? BaCl2 aqueous and BaCl2 aqueous, this is not required. So what is required? Required is BaCl2, this one, and then here is what is there, that is H2O, this is required. And what it is going to form here, you can see this is directly forming BaCl2 dot 2H2O, and this is solid. It means in this reaction these things are not required, so we need to add out. So if you are adding, so how much you are going to get, you can check it out. 8.8, then it is going to give 20.6. Add out, so how much is coming? 14. Carry 1 is 1. So 9 and 2, 29.4. This is value is coming in the term of energy release. Na? Everywhere energy release, but they didn't mention the positive or negative, they didn't mention. Okay, because energy is here in this process getting released. I don't know, little bit mistake they have done in the question, because if energy release means this has to put the negative. So this value they are coming how much? 29.4 kilojoule per mole. So it will be the negative sign. So here whatever the question is there, that we need to put the mention negative. So again little bit I am trying to explain you, although it is very tough. Okay, very
Sir,
tough. What?
can you explain this once more?
Okay. See, I am having the salt. Okay, what the salt is there? Moisture salt is there. Barium chloride moisture is there. Barium chloride moisture. You have added where in the water? Why we have added in the water? Because we are going to calculate the hydration enthalpy. So when you are adding the barium chloride, it will form barium chloride dot 2H2O. Where it is forming barium chloride, PPT will form, precipitate. And what will happen? Aqueous medium is moisture will be as separated out. So barium chloride aqueous is there. Then you are adding in the water. So it is going to form barium chloride dot 2H2O, and aqueous medium will separate out. Another thing, another condition they are talking about, what they are saying, barium chloride plus aqueous medium is there. And if you are changing this one, it is converting into BaCl2 aqueous, solution is forming. They are saying the enthalpy of solution. So enthalpy of solution they form. And here is barium chloride is there. It is formation for this one they are talking about. Barium chloride dot 2H2O. Barium chloride dot 2H2O. They have given 88 minus 8.8. Another is there minus 20.6. Both value they have given. What I'm saying, some terms are not required. What is not required? Aqueous and aqueous are not required. We cancel out. Another thing is what is not required? Barium chloride, aqueous not required, aqueous not required. So what is left? Left is barium chloride plus 2H2O. Here is what they are left required, that is barium chloride dot 2H2O. So if you add it out, this value will going to come. You write down, I'll give some other problems. Maybe it will be, it's going to be little bit tougher problem. One second, you write down. We'll give one more problem if you solve this. This problem is getting tough. Are you writing? Are you writing?
Yes, sir.
Mhm,
Yes, sir. Yes.
mhm. This is very, very tough actually. Hydration enthalpy problem are tough to understand. So in the next class, I'll explain 1-2 problem on hydration enthalpy. What is one parameter? So P is hello, Jana.
Sir, yes. 1 minute, sir.
No problem, no problem. I need to explain this one. The next class I will explain again this. Okay, little bit this problem is there, confusing one, because the question is itself little bit confusing. Hmm.
Oh, yeah, done, sir.
Okay, Janab, again I will explain this problem. Little bit no
Yes,
mistakes in there in this one. So can we
okay,
solve in
sir.
the next class?
Yes, sir, sure.
Huh.
Sure, sir.
Okay, okay. So we'll do some more problem from your book also, and this one also. Okay.
Yes, sir.
Okay. Bye, 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 bye. Take
Yes.
care.
Bye, sir. Thank you.